Let's go. Hey, good morning, everyone. Thanks for waiting. So now let's start our webinar for today. Our topic will be electromagnetic simulation for permanent magnets and wireless charging. So first, let me introduce our company. We are Singularity Engineering. We are a Bay Area based company, and we support full portfolio of ANSYS simulation tools, which includes from EM, mechanical, fluid dynamics, etc. So here on my screen, as you can see, this is our tool called Discovery M. In this tool, we include all the basic simulation for structural, fluid flow, thermal, electromagnetic, etc. And today we will using the electromagnetic module. So let's start simulation. So first, when we click start here, you can see whether we can create a new geometry or we can import a new geometry. So for the first project I'm going to do is I'm going to do a wireless charging. So I will put two coils and provide current to one coil and then it will excite the other coil. So I will show you how we can import the geometry and how and what type of files we can import. So let's next. And here, as you can see, we can choose many type of files. So since ANSYS is partner with many CAD tool companies, so we can insert like step file, um, we can also insert set file and SolidWorks, etc. So I have a wireless model here. So let's open it. And it might take a second since the file I'm importing is a pretty complicated one, but it will give you the idea how it looks like. So now it's creating the geometry. And I see that the quality is not so good. Let's see. I believe if you want to click on 720, yeah, you can get the HD quality because on my side I don't see a good quality here, but hopefully you have a better internet. It might take a while. Okay, now we have the geometry. As you can see here, we have two coils, and this is the geometry I created. And here on the left hand side, you can see which type of electromagnetic simulation you want to do. You want to do pure electric or you want to do electromagnetic. So I will select the electromagnetic and I want to apply current, AC current, and I assume this will be 15, 150 kilohertz. So let's do it. And you you don't need to set all this option right now because you can add it anytime later. So this is kind of like a guideline that guide you through your settings. So if we go next, here we, you can either create a surrounding like air box automatically, or you can create your surrounding manually. So if we go next, and here you can pick like what material for the regions. So I will select one and I will choose anything for now because this is not the model that we are going to simulate. And you can also set the material property anytime in the physics here. As you can see, it's generating the physics. And here will be the geometry, and the rectangular box is the air box. So give it a second. It's creating the physics and the results. So as you can see here, we have two coils and this air box here. And on the right hand side, you can do the selection for face model and the transparency or etc. So let's hide we can hide the body for now. And here. Another good thing about using this tool is even though you imported your project, we can also modify your design anytime at whenever you want to. So here, if we go geometry and edit geometry, you can see it will direct you into our SpaceCam, a 3D modeling tool. So here, let's hide the enclosure, and here you can do anything you want. Like so I will first delete everything because this coil is too complicated and the simulation time might takes a little bit longer. So I want to create a very simple one and show you how fast the simulation can take and how easy we can create geometry using our tool. So first I will delete all of the geometry here, and now we have a empty plane right here. So let's first creating I will also create a two coil antenna, two coil. So that's for the wireless charging purpose. First, I want to create a straight line here. If you click here, you can give a right view. First, I want to draw the straight line, and the use of the straight line is to create these two coil. So when I click on drawing circles and then I enter 0.5 millimeter for the coils, enter, and as you can see here, and on the top here, I want to draw another one, 0.5 millimeter. Okay, so now we want to create our coil. So by clicking pull in the design section and then select the face, on here you can see you can revolve along a straight line. So that's the use of the straight line here. So when you click on the straight line and then you just drag and pull. Okay, um, face, and let's drag and pull. Sorry. Okay, let's do it again. Um, Click on the face here, here, and then we drag. And you can see here it gives you the value. So I think 360 degrees, 6.4 radians. Now we can create a coil like this. And we will do the same thing for the upper tiny circle. Revolve, click this, you pull it, and you give your radians. I want to do 6.4. So 6.4. Hmm. Okay, let's do it again. Click on the face, remove, and you can see, or you can just simply drag. But okay, they are connected. So now you can see two coils like this. And one smart trick you can do is you want to move them to a new component. If you are not moving them into one component, separate components, there if you have something connected, and but you don't want them to be connected, they can be a same component. So now let's create this as a transmission, and this will be our receiver. So, and another thing you need to do is we need to create a excitation port for the coil right here. So first we want to split this. Okay, just click on the split, choose where you want to split, and then get rid of the other line. Now we have our split here, and we split the bodies along this circle here. So now you can see it's created into two half circle. So we can hide one, and on the surface here we want to create a circle, and it will be the same size as the coil. Enter, and now you can see the curve right here. So we want to create this circle into a surface by clicking this um, face curve here. So now you have the surface, and this will be our excitation. So the next step is we want to combine these two half coil together into one. So we make sure they are one coil. So let's select this. Okay, combine, and now they are into one coil. But you still will have the surface right here as your excitation port. And next thing we need to do is we want to create a air box. So go to prepare. Here you can see the enclosure. Create an enclosure and select the coils. Now it gives you an enclosure here, and let's do 0.01. So it's 1 centimeter for the size. 0.01, 0.01, and hit enter. Then it will give you the enclosure here, which is your air box. And now our model is pretty much set. So now we can close this, and it will update automatically. So as you can see, we have airbox. Let's go ahead and hide this airbox. So now you can see two coils. Simple and easy. So next we could do physics, and it will give you all this attention required mark. This means you have something wrong in your design. So either you can right click here and try to fix it, or you can just click at the physics session here. So what it means here is you didn't include all the projects. So let's show all the you didn't include all the parts. And let's select here, click on this, select all the parts, and replace them. Now we have four volumes. The four volumes includes like airbox, two coils, and one surface. So let's go back. Here we can see the material assignment. So we want to assign the proper material to each part. So for the outside part, we want to replace it, and it's air. That's correct. And if we go back, we want to select the other one. So now let's hide our air box, hide body, and now we can select these two coil, replace them, and we want them to be a couple coil. And in here, you can see all your material property. And in any case that you are interested in your own material, you can create new anytime. Let's try it. So when in create new, you can edit your material names, description, and default state solid, liquid, gas, and you can add different material property. Just add the material that you needed. So let's go back. Now we have the material as copper. Great. So go back and let's check the physics options. Edit co coalesce computation. These are program controlled. So pretty much if it doesn't give you the attention required, you don't really need to worry about it unless you have your specific uh, thing that you want to do, so you can edit anything there. So now let's go to the current. So here is where it allows you to assign your excitation. So I created a surface at the bottom coil here. So as you can see, we have this surface. Same thing, we want to add this phase or volume into the excitation. So we'll assume I will use 5 ampere for the current, and no phase, everything is the same, and you can set the polarity so to be reserved or just leave it as default. So the current is done. And here, one interesting thing you can do is the skin effect. So let's now show all the parts, and let's hide this one. Here, you can define where you want the design to have skin effect, and definitely it will be the coils here. So I basically just add it, and then you can choose your resolution. You want how accurate you want it to be. So the more accurate, the more time it takes to simulate. So let's go back. I usually just say as default. And before we can go and solve the physics, let's take one more interesting thing, the solver setting. So in the solver setting, you can adjust the simulation speed and trade off with accuracy. So here, faster speed means lower accuracy, but higher accuracy means slower simulation speed. So I will put it as default. And oh, you can see here as well, you can like the surface meshing as well. So how accurate you want it to be. Generally, we just leave it as default, and we can take a look of the results first. So this is pretty much all for the wireless charging setup. So let's solve the physics. And in this one, it will typically take few minutes to solve this project. Okay. One more thing I need to show. Let's stop here. Okay, so we have the launch control. Here, determine how many processor you want to use, how many cores you want to use. So let me do 4 because I don't want to take out all my speed because I'm going to do another permanent magnet simulation while this one is running. So I don't want to use all the number of cores. So um, I will solve the physics, and now we can let it run. So this is pretty much all for the wireless charging setting in Discovery M. So next, let me go ahead and open another window so I can show you how we can set up the permanent magnets. Feel free to ask any questions if you yeah. So now we have the window open up, and let's go ahead create another geometry. So now besides import the geometry, now I just define my geometry, and next. Oh, as you can see here, there's another option that I forgot to mention is connect to the cat tool actively. So while your cat tool is opening, you can connect it with Discovery M. And if you are not used to the SpaceCam integrated with our software, you can modify in your cat tool anytime, um, and then bring it, and it will do the real-time synchronize and bring to the Discovery M. You can just edit your model in your cat tool. So now we have this window. We want to use permanent magnets, and we'll leave anything unchecked. And we are using constant temperature, if I forgot to mention. Let's go next. Here, because we don't have any geometry yet, so we have to create the surrounding manually, which is the air box. And for the air box, you can put other gas instead of air if you want to. So you can do that in the material management later. So I will do everything as default. Now we open up the space cam here. Um, Let me draw a very simple magnet. So I will draw cylinder magnets. So let's do it. I assume 2 centimeter diameter, and you basically just doing the same thing. Pull, and let me. Oh, and when you pull, you can also enter the value that you want it to be. So let's do 5 centimeter. So this is a cylinder magnet, and so this is a permanent magnet. So like some people is interested to see like a middle is a metal rod, and then they want to create some coil around this rod. Then basically you can just create another let's do it, create another cylinder that is bigger than this. So let's do it. Um, so I will 2 centimeter. This time I will do 3 centimeter. Okay. So the oh, that's probably too big. But anyways, I will just go ahead and do it first, and I basically pull, and you can make this face to align with this rod. And now you can see, because you didn't create like move them into a separate component. So when you create it, they are merged together. So what we want to do here is before that we want to move this solid into a separate component. So this is a rod, and I will create. Now I have this surface. Now I'll create another one, and here. So this is a outer coil, and you can definitely make it a different size than your rod, but to serve the purpose, I just make it as simple as I can to make it quicker so everyone can see. So this will be our coil, and now, okay, I see someone is asking a question. I will answer the question at the end. So let me finish up the all this setting first, and I will answer your questions. So now let's go to physics. Um, all of these settings are the same um, for the apply current, but oh, I believe I choose the permanent magnet in this case, so it may not give you the options. But when you select apply current under this electromagnet, when you assign the ports, it will allow you to create how many windings for the coils. So how many winding for the coils, and you can enter the number. Let's say 100. There's 100 winding for the coils. You can enter 100, and treat it as a it will treat it as a 100 coil in the simulation. But because we are doing permanent magnet in this case, so it doesn't give you the electromagnetic conditions for the applied current. So I cannot set it in this case. But yes, if you remember in this coil design, you can set the winding. So let's go back here. We will go back to our permanent magnet simulation. So let me delete the coil, and this will be our permanent magnet, and let's create a air box. So select this. I want to make it a bigger air box, so maybe 0.03. Sure, 0.03, 3 centimeter. 0.03. I think it's big enough. Oops, sorry. Do it again. 0.03 and hit enter. There we go. We have the air box. So now let's go to physics. We need to include all the parts in the simulation. And let's assign the material. So first is our air box. As I was mentioned, you can select any gas you want. So, or you can either enter your uh, special gas if you are interested in any type of gas. So we need to assign the permanent magnet. So let me go ahead and hide this box here, and this will be our magnet. So I was using nickel 5. That's a material property, one material for the permanent magnet, and you can also import BH curve if you have like a special magnet that you want to have import use, and you can also import the table for your BH curve, and you can edit all the material property right here. So I will just use a default material in the library. So let's go back. For permanent magnet, the setup is pretty easy because you don't have many options to change other setting. Um, so let's use. I will just use 4. And solver setting, everything is default. And let's see what happens here. This one might take a few more minutes, I assume. And let's go ahead and solve the physics. And I see someone is asking, is it possible to do change analysis inside the M for electromagnetic simulation? So unfortunately, in Discovery M, we cannot do the changes analysis because Discovery M is made for easy use case. If you want to do any advanced setting, we have another um, software is developed for this specialized in electromagnetic simulation that's called Maxwell. So if you look up ANSYS Maxwell, it includes many other advanced options that you cannot do in Discovery M. But in many cases, like our customer find that Discovery M serve the purpose for their needs. So and it's a lot cheaper. So they are happy to use Discovery and then getting Maxwell because Maxwell is meant to solve more complicated geometry and it has more powerful solver and it costs more. Definitely have more ability. So now let's wait for this one is almost done. Both are almost done. And another good thing is using Discovery is in one software you have many other type of module you can use. For example, thermal. So if you are doing a simulation in electromagnetic and you want to see the thermal condition, you can always bring it to the thermal um, module, and then it will give you a it will bring the data and then give you the run a quick simulation and give you the um, thermal condition and thermal statistic. Yeah. So okay, this one is done. So let's go to results. It's generating a contour itself, so it might take a little bit longer. So here's you can see the contour, but we probably don't want to see this because this is linear. So let's create our own contour. And up here, so on the left hand side here, you have results. So if you see the attention required, that means um, it you didn't define any location for your results yet. So it just give you attention, require attention. It's not meaning anything goes wrong in the result simulation. It just no results, no result is given in this. Yeah. So let's for the so first we want to create a plan. So if you are interested in seeing 3D contour, we can go ahead and show. Actually, I need to show all. So you can select your airbox, and then we want to see the EM field, magnetic field intensity. So here you can select logarithmic and evaluate. Then you can see your EM field in 3D. But I mean this is based on the airbox. So here it will also give you the minimum value calculated in on this airbox and give you the maximum value. But this is not quite making sense. So I want to make it easier to look at. So let's go back to result. I want to hide this body, and I want to create a plane. So create a cut plane allows me to see the 2D EM field, magnetic field much better. So let's do it and as Y. So let's look at it. This is Y. So we want to move it a little bit upper in the Y direction. So I remember I was using 5. So let's do 2.5 centimeter. Okay, 0.025. Okay, now it's centered. And this cut plane is also um, so let's go back. Sorry, let's go back and here go to our contour. And now we to create a new contour for the location. Select the plane one, and what variable you want to see? Magnetic field. Appearance. Okay, do logarithmic. And now you can see your magnetic field, and it will where you point at, it will give you the value here on the plane, and it also generates the minimum intensity, the magnetic field intensity, the minimum and the maximum here, so you can have a very clear look. And or if you are interested at some point, you can always point there. And there's also another way to give you the data along the axis. So that's going to be another thing you can do is we can go ahead and create these start points. Let me create new. So for the start points, I want to from because my model was created from the origin 0, 0, 0. So I want to do 0, negative 0 point 0, 0.0 2.5, I guess. Oh no, 0.025, sorry. 2.5 centimeter. And I will go ahead and create another point. Create new. And this one I'll do a 0.075. And I see someone is asking, will this video be available after the event's over? Yes. I will. This video will be posted on YouTube, so you can share it with your colleague or take a look anytime later. And that's thanks for asking that. So now we have this line here. So and you can also create a horizontal line across this to see the horizontal magnetic field. But uh, right now I just create one line and show you the how we can plot the line plot. So let me go to the results. I want to add line chart. So this line chart, you can add your line. So let's see what the magnetic field intensity. Let's add it. Evaluate. Oh, sorry, I didn't check the. Yeah, but there we go. Now it creates this line chart for the magnetic field, as you can see from um, distance 0, 0 away to 1, because here is a starting point 0, 0, which is at axis negative 2.5 centimeter. So here from, but it will start counting from there, and you can see how the magnetic field intensity increase and drop across this permanent magnet. And of course, you can um, create many different lines. Excuse me, and have soldering in here, and you can also export the CSV file, so it give you all the data along this line. So this is for this, and um, if you want to see how the electric field, the direction of the electric field, so you can go to the vector. So I didn't do that part, but you select plane one, or you can do a 3D, select the airbox, anything you like. So basically, I will go ahead and do a magnetic field intensity. 3D arrow, smooth, evaluate. And as you can see here, this is how the This is the EM field. So this is not very clear, but you can see it's coming out here and going back the other direction. So here it's like this coming out. But let's see. Okay, so I think this is going in. Yep. Let's go ahead and take a look of the 3D. Let's go ahead and select the airbox. I need to saw off first. Saw off, and I will select this, and let's do a quick evaluation. It's pretty messy. Yeah, now you can see the 3D um, EM field. So another thing you can do is you can set a believe here. See, you can look at all the EM field, but at outer part, there's the intensity is not as strong, so it doesn't really give you anything here. So we do it based on magnitude. Um, let's see. Okay, and we can also look at the magnetic flux and do a quick evaluation. There you go. So you can take a look of different value here, and you can also do a. Yep. So here is for the magnetic flux density. So it gives you the minimum and maximum at where you are, at the plane that you created or the location that you created. Yes. So let's go back to results and see what else we can do. And we can also do the calculated value. So function of calculator, pick your location. Let me go ahead hide this for now. Um, so I can do it. Um, let's say pick a location. So let's see. I'll pick this route. This may not make sense, but just give you the idea of how you can do this. So you can see the loss, ohmic loss, total loss. You can see the total current, total magnetic flux. Yep. So or you can just go create a dot. Let me see if this works. 000. Let me do it at 0 point negative 0.0025. There we go. So I create a point at there. Hmm. Yeah, this may not create give you the calculated value here because you don't have. I assume you don't have any the variable location. Select one another face apply. Okay, so it wants you to select a face. So let me select this face. Okay, there we go. So if we select the face, it will give you, you can calculate any of these. So you just pick anything. I mean, it doesn't really make sense to do it on the magnetic in this method, but just giving you the idea of you can the how the function calculators work. But we can definitely do this in the this coil antenna here. Oh, it looks like it's still generating something. So let's see what happened. It's not responding. It's not a good sign. So yeah, so this is pretty much all for the permanent magnet simulation, and feel free to ask any question on this part. So I will go ahead and close this, and let's see what happens here. Okay, let me go ahead and save this project first. Let's go to uh, webinar, discovery and permanent magnets. Let's save this. Yes. Once I save this project, let me close it and see if the other one responds. Yeah, because I'm working on my laptops here, so it's not as powerful as a workstation. So sometimes when I'm running more than one simulation, the software may crash. So hopefully it doesn't crash on me. So sorry. Okay, there we go. It comes back now. Comes alive. Okay. So let's go to result. Yeah. It looks like going back down. Sorry for this, guys. Please be patient. So let me try to open another design that I've done before. That one, the same design, but that one has a result already. So let me see if I can launch that. Um, or this one is probably just generating the contour automatically. That's why it takes longer. Dylan is asking a question: if there was a pair of magnets, could Discovery M calculate the force from one magnet's field interacting with another magnet? Yes, it can. So if you have two magnets, you can always so one magnet field. So I think in Discovery so I will take back my yes, but I believe in Discovery M you are able to see the magnetic intensity or magnetic field acting on both magnets. So let me rephrase this. Um, So let's say, so you are able to see the coupling magnetic field, but for the magnetic force acting on one magnet from the other magnets, I haven't tried out on Discovery M yet, so I have to look into that. But if you are interested further in this topic, you can feel free to email me, and I will definitely look it up and let you know. Yes. So, but this ability may or may not exist in Discovery M, but definitely exists in Maxwell. So in Maxwell, you can definitely calculate the um, magnet magnetic field interacting with another magnet. Yes, for the but for Discovery M, I have to look into that. So please send me an email if you are interested in further discussion on that. So looks like this is not responding. So let me open the other one that I've done already. Let's see what happened over there. So let's see what will happen here. Sorry. Hmm. Looks like I need a better workstation, a better computer on this. um, guess this is not giving me a good sign. Yeah, but um, well, we cannot see the results yet. But just to save your time, I will do a quick explanation. So if you want to see the magnetic field, magnetic intensity, etc., um, for the for this two coil wireless charging device, you can do the same thing as, oh, it comes back. Yes, it comes alive. Thanks God. Um, so let's now I can show you. There we go. There we go. So I will now close this counter. Now we have this two coil. Um, let's look at so um the way you want to do it for this wireless charging is the same as you want to do in um why so in permanent magnet. So let's create a coupling first. I'll just set it yes, go back, choose plane 1. So it's 150 kilohertz. I want to do the magnetic intensity or appearance. I want to do logarithmic evaluate. So as you know, we input the current at the port here. So here is the magnetic field generated on both coils. So I see you can see here. Here's another coil. So let me make it more easy to see. Um, So this is for the cut plan to see the coil. But if we want to see the let's do this. So mesh. Okay. So next, let me show you how we can look at the. So we are interested in the current, right? So here you can see we can let me do this real quick. Um, Current density for the two coils. So you can see here and evaluate. So I don't think um, anything is fine. So as you can see here, we have the current is 2.9, but I imported 5 ampere for the current. So here's the current intensity. And another thing we can do is we want to see the current intensity for this upper coil because we excite the bottom coil, so it will generate some currents at this upper coil as well. So when we point at this, um, when we point at this, we will see there's some currents right here. There's current intensity. I mean, you know how to calculate the current from the current intensity. But yeah, we can see some current here compared to outside is almost none. Yeah, it's like zero. So another way to give you a better view is create a cut plane along this coil. So what you can do is this: create this cut plane. So we have 3 minutes left. I will do this as soon as I can, as fast as I can. So let's do this. This is 0, and this is 1. So now we can see there's a cut plane along the coil. So I want it to be to at a coil location. So what you can do is you can do a axis, but we want to so it's actually right here. So we want to do it as based on geometry selection, because sometimes if your coil is not at the origin, it won't give you a good location to see the coil. So based on the you can click this, and you can see it will align with the coil. So let's this bottom, and let me create another one real quick for the top. So one based on geometry selection, select this. Well, you don't have to select it because this coil is at the origin, but we'll do it in case something messed up. So this is top, and let's go back to results. So contour, we want to do something new. So let's do a top one because we are more interested in the current density for the top coil. So everything is good. Let's evaluate. Yep. Now you can see your coil is excited from the bottom coil. So and you can see the current. And if you are interested in the line chart, you want to see the current at a certain point, you can do the same thing, create this line or at any points, and then you can create that line chart. They are created in the permanent magnet simulation, and you can export your .csv file as well. So, yep, this is pretty much all for today. And oh, one more thing I need to mention is you can do that functional calculation. So here calculate the value. So you can function, and here pick a location and select the value. We can look at the loss, total loss, core loss, and any loss, and you can calculate the value, the loss value from the coil. So it's 11. We have been in the webinar for an hour, so I will stop here, and thanks everyone for joining. So I see there's somebody asking a question, semi student. I would like to add another as between them. Yes, you can definitely add any geometry you want between them. It will give you the it will calculate the magnetic field intensity and you can measure it at any location you want. But in Dylan's question, he's asking, can we see the force that from one magnet and interacting with the other magnet for that part? In discovery, I'm not sure if it can do it, so I have to look into that. But in Maxwell, we can definitely do it. So Maxwell is another more advanced tool that's specialized for electromagnetic simulation. Yes. So are there any other questions? So let's finish this. I will select the face. Um, so I will give a couple of minutes here, and feel free to ask any question. But yeah, so if you are interested in any further simulation or any other topic, feel free to email me, and we can discuss furthermore. So there's another question. Can relate this simulation with a mechanical analysis to measure how much force can put 1 minute before the breakdown? Yes. So in Discovery M, there's also I believe there's also mechanical simulation in here. So I haven't done something similar to like uh haven't done something in mechanical part yet, but it can definitely calculate the force and uh, bring in the data that you simulated in this EM simulation to the mechanical, and then and then it can calculate the force in mechanical on mechanical side. So if you are, yes, same thing. If you are more interested, I can you can email me, and then I can refer you the mechanical expert, and he can talk to you about how you want to do your project or how you want to model your project and what you want to do in mechanical. So I will do a total loss. Are there any other questions? Yeah, so now we can evaluate the total loss on this coil. So here's the value for total loss. And you can do any other more. So let's see if there are any other questions. Uh, if no questions, I guess I will stop here. And thanks again. Thank you guys for joining the webinar today. And if you have any questions, feel free to email me, and I have my information attached below in this link. So, and this video will be posted on YouTube in our channel as well. So feel free to share it with your colleague and look it up anytime that you are when you are interested in simulation. All right, thank you guys. Thanks a lot. You guys have a good day.